In this experiment, we're going to try to do something that's in the core of statistics and sampling. And that is, does a random sample accurately reflect the secrets of a population? If it does, then we know the random sample can be used to find valuable information about the population. To do this, we're going to do an experiment. Let's assume we actually know the population and see how random samples behave. And if in this case they behave well, then they will behave also just as well in cases where we don't know the population. And that's the goal of statistics. This experiment is going to have ramifications throughout the course, so I want you to pay close attention to it. To do this, I'm going to assume a bell-shaped population with an average of 70 and dispersion of 9. We'll call these some things later. So I'm going to take a command, and this command is going to allow me to take random samples from the population that I already know its parameters. By putting the equality sign in front, I can take the sample, and I am going to actually take 50 of them, 50 observations in each sample. So I'll go to 53. That should give me 50 observations. And I'm going to quickly copy this by saying, keeping my finger on Control and pressing C simultaneously. And then I'm going back and pasting it as values. That converts my equation. So paste special as values. If I don't do that, it'll continue changing on me anytime I move around. So let me see if I've done okay. No, this is still formula in there, so Control Shift down highlights everything. I think I didn't highlight everything. So I'm going to say Control C and Home, paste special. I'm going to fill the values bubble. Okay. So now I'm going to also do the same thing. I'm going to take the same command and go across for 4 more. Control C simultaneously and Control V. What I'm going to do is, I guess I have to put the equality sign there, and gave me another one, and I'm going to go 4 more. Just 5 samples of 50 apiece. So I'm going to drag this down as well. I ended up with actually much more in my sample. That's okay. So I'm going to copy this, Control C, okay, and go to Home, paste special, values, okay. I took larger samples than I wanted to, so I'm going to insert a row in my Excel sheet. You can do that on Excel, and call this sample 1, and drag it to the rest of the cell, sample 2, 3, 4, 5 samples. Now I'm going to go down, and I'm going to count them. So let me put a counter because I lost count. I think I've got something like 90 or so, but I want to make sure. So 1, 2, and I'm going to count this and see how many I got. I got 91 observations. I'm going to take the averages. So let's take the averages of each sample. Sometimes they're called X bars, X with a bar sign on it. Okay, so X with a dash on it. So I'm going to calculate the averages is going to be equals to sum of all of these. So I'm going to pull them up. I don't want to copy everything, just up to that point. Sum, and I divide it by count. I know the count, but I just wanted to show this command to you as well, which is going to be Control Shift down again. It counts it for me. That is going to be 91 unknown. Now if I grab that corner and drag it, it's going to give me all the averages from each sample. Note that our population average was equal to 70. All of our samples are hovering right around 70, very close to 70. So if I draw the conclusion that the random samples did very well in showing the population mean. What this means is that in cases where I don't know the population mean, I still can get it from the random sample. It's very important. So random samples are very useful. That's why Census Bureau and everybody else, businesses, take random samples. Now we are going to see hypothesis testing in the future. And I'm going to do a crude hypothesis testing. This is called the null hypothesis. And I'm going to choose an alternative. Every hypothesis should have an alternative. So alternative, or some textbooks are going to call it H1, some of them are going to call it HA. I like H alternative or HA better. Let's say if I say population mean is equal to 120, and then population mean not equal to 120, this is how you set up your hypotheses, as we're going to see in the future. Even without getting sophisticated, it's very, very unlikely that I would accept the null. I would probably reject the null. Why? Because my samples don't verify that. My samples say the population mean should be around 70, not around 120. So two conclusions. Samples don't lie. That's conclusion number one. Number two, in all cases, you will, in cases that we don't know the population, whatever samples tell us, probably that is a bona fide sample. Large sample of random observations probably reveal the secrets of the population, and we can rely on them. So I hope I like this experiment quite a bit, because it's got ramifications on the entire course of stats. Thank you, and that's that.